So dispersion is the measure of variations, I should say. Like we will talk about the degree in which the data tend to spread like about an average value, like which is mean, but not actually mean every time. We're going to look at different things. So basically, we are going to look at the data that how much dispersed it is. So let's now read the definition. The measure of the scatteredness of the mass of figures in a series about an average is called the measure of variation or dispersion. See, measure of variation or dispersion. So there are four measures: range, quartile deviation, mean deviation, standard deviation. And also in standard deviation, we will also look on variation. Okay. Then first let's talk about range, the different range of data. So range is the worst measure of dispersion because it's only talk about the maximum and the minimum. So first let's talk about how do we find the range. So range is simply find it out by looking at the maximum observation, maximum data, and looking at the lowermost to the minimum data. Then we take the difference, and that is our range. That is termed as our range. So this is the worst kind of measure of dispersion that we have, in which if the let's say L is the maximum observation and S is the minimum observation. So the range will be given by L minus S. As simple as that. Let's take an example of ungrouped data. 5, 10, 3, 2, 1, 80, 45, 44. So this is the data, ungrouped data that we have. What is the L? What is the maximum value here? And what is the minimum value? Can you spot the maximum value, anyone? See, I would really
E-
appreciate your attention in the class. Yes,
80, sir.
yes. It is maximum. And what's minimum?
1, sir.
Yes. So the range is L minus S. 79 is our range. That's how we find the range. Let's now talk about the coefficient of range, where we are looking how range is ranging, actually. So it will simply find it out by L minus range, S, which is actually range, divided by L plus S. So L minus, so if you find out coefficient of range for this ungrouped data, L minus S upon L plus S. So that becomes 79 on 81. So this is our coefficient of range. And this is very easy. Is this clear?
Yes, sir.
Let's now talk about quartile deviation. So this is not important, but still let's discuss. Quartile deviation of semi-interquartile range Q is given by Q is equals to 1 by 2 multiplied with Q3 minus Q. Its coefficient is given by this, where Q1 is the quartiles of the distribution. Quartiles of the distribution means, let's take an example then. So Q1 is actually lower quartile and Q3 is upper quartile. And this Q will come out as semi interquartile range. Or we may also call it as quartile deviation simply. And there will be no questions asked from this topic. That's a risky line to say, but no. Yes. So Q is simply 1 by 2 by Q3 minus Q1, and Q is Q3 minus Q1 upon Q3 plus Q. We'll look at its example later. Very important. We are talking about deviation. Deviation of certain data about its mean. That how the data is deviated from its average, which is its mean or median or mode. So we will talk about its deviation. Okay, so let's read the definition. For frequency distribution, mean deviation from the average A usually uh, mean deviation from the average. It can be mean, median, or mode is given by Fi into Xi minus of A divided by sigma of F. Should I write it in the different format? Mean deviation. It will be easier for us to understand. Xi minus mean divided by n, where n is the total number of observations. It can be given by sigma Fi as we know, and sigma of Xi minus x bar, x bar, where x bar is representing its mean. So this is actually the formula of mean deviation about mean, because we have mean here, right? If we have certain other quantity to measure with mean, median, mode, or ungrouped data is given. Ungrouped data mean or frequency data, ungrouped data, when we call it the class, then frequency is given now. So then we also multiply the frequency with the xi, and then we also multiply with the first we are multiplying fi into the both of xi minus a, which is the difference. So let's take an example that will make things more clear for us. There was mean deviation. Let me look for its example. So there is an AP 258 till 21. This is an AP. We have to find the mean deviation of AP from its mean. We have to find the mean deviation from its mean. This is the question. Okay. First, we know for finding the mean deviation, we need to find the mean, because that's what we have to find first. So the mean is simply the sum of whole terms divided by the number of whole terms. That will be your mean. Okay, so the sum of n terms. First, we have to find out how many terms are there. So if this is the last term, a is equals to a plus n minus 1 into dt is actually 3. So it becomes yeah 21 minus 21 minus 2, 19 divided by 3 is equals to n minus 1. So n becomes 19 plus 3, 22 divided by 3. That is our number of objects. Actually, I'm doing some mistake, I guess, because number cannot be in fractions. So 2 plus 2, 5, 8, 21. Okay, 21 terms are given. It is like that. So it's actually not the nth term, it is the n only. It is written like this. 21 terms are given in AP in the question here. So these are 21 terms, not the nth term. So if we have total number of then we don't have to find out n now. 21 by 2 into 2a. A is 4 plus n minus 1. So 21 minus 1 is 20 into d, which is 3. This is the sum divided by the number of terms. 21, 21 cancels each other. 20 plus 3, 20 to 3 become, okay, let's divide 20 by both sides. So this becomes 2 plus 30. That becomes 32 is our mean now. Okay, great. So that's our mean. Let's find out sigma of xi minus x bar. So this is 32 minus 2, 30. 32 minus 5. 32 minus 5 is 27. 32 minus 8 is 24. Then 21. We have observed a pattern now. 18, 15, 12, and like this, and it will go till the last term. 20 last term is the 21st term. So the 21st term. So this will go on like this. We have find out that this is an AP with A as 30 and D is minus 3. And this will go on till 21 terms. Okay. So we can find out its sum using the SN formula. 21 by 2, 2A plus n minus 1, that is 21 minus 1 into D, which is minus of 3. Okay, nice. 2 divides it. 15, 10. This becomes 21 into 15 minus 30. So minus 15. This is the sum. Now, how do you find the mean deviation? Mean deviation is found by sigma of xi minus of x. But we are doing a mistake here. We are doing a mistake here that that we cannot apply this formula. Why we cannot apply this formula? Because there is modulus here. We cannot take negative value. After like it's 0, then 3, 6 will be written. Why? Because there's a modulus here. Okay. So nice that we have remembered. So let's try to find out on which 0 is which term of the GP. 0 is equals to 30 plus n minus 1, that is we need to find out because we don't know the n. D is minus of 3. So so this goes onto the left hand side, makes itself positive. 3 cancels 30 by 10 and becomes 11. So this is the 11th term of AP. How many terms are remaining? 10 more terms are remaining. So this is the first, second, third, and similarly till 30. Those 10 more terms are remaining. Okay. So I am, let's find out how many these are this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And then again 10. Okay, nice. See, we have got the gist now. It's an AP getting multiplied twice. Now we can find out the sum. How? We can like this is one pair and then 0 and then again the same pair. So this is actually the same GP. You can find out its sum 2 into the sum of the number of terms are 10. 10 divided by 2 into 2a. 2a, we can take a as 3. Let's take 2a into n minus 1, that is 9 into d, positive 3 this time. 2 cancels, no, 2 will not cancel. 2 cancels 2. This becomes 10 into 6 plus 3 into 11, 33. So 330 is the sum. Okay. And how many terms are these? 21 terms. So mean deviation will become sigma xi minus x bar divided by 21. So 330 divided by 21. This comes out as cancels by 3, 110, 7, 110, 110 by 7. That's the answer. That's a JEE level question. Clear? Not JEE level 2, but JEE mains type. Understood or should I repeat?
No, clear, sir.
But just you have to be aware while doing calculations. Do not do any minor mistake. So that's about mean deviation. And if it is given to find out the mean around median also, we can do so by simply changing the E. Next comes the standard deviation. Okay. So standard deviation is also a deviation when we discuss about it. And yes, it is denoted by a Greek letter sigma, like this. Sigma, there are multiple formulas for this. Xi minus x bar, same but square this time, divided by n. Or you may also write sigma xi square, means every element square, divided by n, minus sigma xi divided by n, which is actually the mean square. Okay, you can also replace it and write mean square here. Or you may write its formula too. It's very important for you to understand. Okay, so these are two forms of standard deviation formula that are given to us. Now let's talk about variation. Then we'll talk about an important property for this. But first understand this is for ungrouped data where Fi is not given. When Fi is given, simply multiply it. Nothing. N is capital N because N is sum of all frequency. That's nothing changed. Just that Fi is getting multiplied here. Simply. Okay. Let's now talk about. So this is the only change. Don't remember these formulas. Just remember these two formulas that I have written with pen. Just understand the difference that whenever Fi is given, Fi will get multiplied. And the total number of observations will become sigma of Fi. Okay, nice. So let's now talk about variation. Variation is just the square of standard deviation. So if it's the square of standard deviation, its formulas are going to follow same root. Just that there will be no square root. This will be the formula. Or sigma xi whole square divided by n minus sigma xi divided by n whole square. So this is also variation. Now, let's discuss about the property of variation. On change of origin. What is change of origin? That is if we plus or minus the elements of the data, then variation remains unchanged. Unchanged. So if there are elements like 5, 10, 15, the variation is given as 5. I'm just giving an example, not correctly. And if I subtract 2 from all of the elements, then the variation remains same. That will be the same, just the same. But on change of scale, multiply or divide, not plus, multiply or divide, then variation will change. How it will change? Let me give you an example. If xi, the element, are getting multiplied with p, okay? If xi is getting multiplied with p, then its variation will also get multiplied, thank you, with p square. Not the p square, because there is square this time. If the element is getting divided by p, then the variation will get also divided by p square. This is important for you to understand. And if there are changes of plus minus in the p, in the element, then array, then there will be no changes in variation, unaltered. Okay. Let's now, if variation is getting affected by the change of scale, then of course standard deviation will also be affected. Yes, they will be. So standard deviation too depends only on change of scale, that is multiply or divide, and not on change of origin, that is plus minus. Okay, and how? If the elements are getting multiplied with p, if the elements are getting multiplied with p, then the standard deviation will also get multiplied with p modulus. P is modulus, and this is literally very important because most of the YouTube lectures just write p there, and they miss on the fact that standard deviation is actually the square root. And if there is a square root, then only positive value will come out from it. And if the every element is getting divided by p, standard deviation will also get divided by the modulus of p. That's why I have first taught you about the variation. Okay, so this is about the variation or variance. Uh, Sorry, I like mispronunciate it as variation. It's actually the variance. Variance. Variation is the measure of variation, not this. Variance. Now some important facts about standard deviation, mean deviation. So let me write it here. I'm writing standard deviation as SD and mean deviation as MD. So 4 times the standard deviation is 5 times the mean deviation. Often seen like this. So the gist is standard deviation is greater than mean deviation, always and every time. Very important. Standard deviation is greater than mean deviation. So let's revise standard deviation first. Standard deviation is given by this formula, sigma of, sorry, what is this? Small sigma, and then the sigma, which is the operator sigma, of xi minus x mean, that is the mean square, divided by n. Or it can be also written as like this, where we are taking the sum of all squares of squares of all elements divided by n minus the mean square. Okay. And it depends on only the change of scale, not on the change of origin. And we have seen how it happens. We have seen the relationship between standard deviation and mean deviation. Variance is just simply the square of the of the standard deviation. It's find it out by this formula same. Similarly, just remove the square root. So on change of origin, it does not change. On change of scale, it only changes. This is how it changes. Let's talk about. Let's talk about the variance for natural numbers. For the first natural numbers. First and natural numbers. It is given by simply n square minus 12. This formula will be directly helpful for you in previous year questions in the paper. So if like I say 1, 2, 3, 4, 10, find the variance of these data. So it will be simply 10 square minus 1 divided by 12. Where 100 minus 1, 99 by 12. This is the variance. Clear about variance?
Yes, sir.
Okay, let's now tweak the question a little. So I have two questions for me. I'll explain the first, ask the second from you. If all the natural numbers between 1 and 20 are multiplied by 3, then what is the variance of resulting series? Okay. So actually 1, 2, 3, 20. This is the series. First, let's find out its variance. We know 20 natural numbers. This will be its variance 400 minus 1, 399 by 12. And it's getting multiplied by 3. So if a series gets multiplied by 3, then its variance will also get multiplied by 3 square. So its variance was 399 by 12, which will get multiplied by 3 square, which is 9. So let's solve it. 3, 4. Okay, so this is our answer. 399 into 3 by 4. If I, let's say, calculate it, then it will come out as oh, 9 3s are 7, 2 carries 7, 3 3 is 9, 9 and 7, 16 divided by 4. So this will be our answer. The resultant variance, the new variance. Because the whole series was getting multiplied by 3, the variance will get multiplied by 3 square. Clear?
Yes, sir.
Important question. The variance of 25 observations is 4 if 2 is added to each observation. Then the new variance of resultant sequence of resultant observations will be what? This is what you need to find out. Think. If we are adding 2 to each observation, what is this? Change of origin or change of scale? Come on, answer. Hello. Hello. Are you there? Are you even trying?
Yes, sir.
What is this? Change of scale or change of origin? Guru Charan, tell me what is change of origin?
Sir,
What is change of origin, bro?
Sir, may I?
Yes,
It is change of origin, sir.
it is change of origin. What is change of origin?
Sir, it is
the value
here
is
that
added or subtracted.
Yes. When we add or subtract, it's change of origin. What is happening here? Change of origin. Do change of origin depends like the variation depends on the change of origin? Sorry, do the variance. Yes. Do the variance depends on change of
Yes,
origin? Yes or no?
yes, sir.
Do the variance depend on change of origin? Yes or no? Come on, please.
Yes, sir.
अरे यार, read on slide. Do the variance depend on A change of origin or not?
It's remained unchanged.
Yes, it remains unchanged. It remains unchanged. So, will the variance change here? What was the variance? 4 will be the answer, na? It will remain unchanged. Easy था ना? Hello. Was
Yes,
it
sir.
easy? Yes, it was
Yes,
easy.
sir.
Yes. Okay, let's take some more questions. So I'm writing the question. Now please answer correctly, okay? If you want to revise, I can change few slides again. Standard deviation is this, depends only on change of scale, not on change of origin, and the formula is this. See how it changes. See how variance is, just a square, and see how it changes. Time for questions. So the variance of 20 observation is 5. If each observation is multiplied by 3 and added with 4, then new variance for will be what? Please tell me. See, the multiplication is change of origin. Okay, so 5 into 3 square because it's variates. The change of plus is the change of scale, which do not changes the variation. So this will be your final answer, right? 5 into 9, 45 will be our answer. Yes or no? Hello.
Yes, sir.
Is this clear or should I explain it again?
Clear, sir.
Okay, next question. The mean of 100 observations is 50 and the standard deviation is 10. If 5 is subtracted, if 5 is subtracted from each observation, then and then it is divided by 4, then what will be? What will be the new mean and new standard deviation? We have talked about mean earlier. So tell me, do mean depends on change of origin or change of scale or on both? Fast. Do mean depend on change of origin or change of scale or on both? Please study. Okay, otherwise it will be hard. Mean depend on both change of scale and change of origin. So what is said that the every element is subtracted from each observation and then they are divided by 4. Okay, the mean will also behave the same. That the new mean, if every element was behaved like this, then every so the new mean will also become subtracted by 5 and then divided by 4, which suggests us that the new mean will be 50 minus 5 divided by 4. 50, 45 divided by 4 will be our new mean. Okay. What about standard deviation? We know standard deviation not uh, changes because of the change of scale. Sorry, because of the change of origin, because this is the change of origin. Okay. It only depends on the change of scale. So it will get divided itself by 4, the new standard deviation. The new standard deviation. Okay, what was the standard deviation earlier? 10 by 4. This is our answer. 10 by 4 and 45 by 4. Any doubts?
No, sir.
So this is how questions can be framed. And also, you will be required to apply those formulas as well. Sometimes. Okay. The mean and the variance of binomial distribution, we have already studied it in the probability case. है So you have to be very much conscious and aware about this particular topic because there are good chances of questions arising from this topic. The mean and variance of binomial distribution, where we are talked about NPQ and the mean being NP and the variance being the Q, or should I say NPQ? NPQ being the variance and mean NP. Okay, let's now move ahead and discuss about the next topic, that is comparison of variability of distribution. So now the variation, we are talking about the coefficient of variation, which will be given by the deviation divided by mean. Deviation divided by mean. By deviation, we mean standard deviation divided by mean. Mean is x bar into 100. So this is the coefficient of variation. Coefficient of variation. Sigma by x into 100 percentage. So this is coefficient of variation. If I just remove 100 from here, sigma by x bar, this becomes coefficient of dispersion. Coefficient of dispersion. Sigma by x bar. Now there are some important observations directly taken from previous year questions. Let me write here that the sum of deviation about median is minimum. Next point, the sum of deviation about mean is 0. And now this time I'm not going to write it again and again. The sum of deviation about mode is maximum. Write these 3 points in mean deviation topic. Okay. Sum of deviation about median is minimum. Sum of deviation about mean is 0. Sum of deviation about mode is maximum. And please, if you do not take notes now, then at least take notes when I say that these questions, these points are particularly picked up from previous year question, because no book will provide you these points which are directly taken from the previous year questions. Okay, so this is about the comparison of variability of distribution. Now there are some other topics here as well. We can study. Now, in coefficient of variation only, so be aware about this fact that in so this see this is what this is the coefficient of variation. Variation is a quality of change, and consistency is just its opposite quality. So the coefficient of variation when the property of some observation of being variable, or it's variating a lot, so its coefficient of variation will be high. It means it's less consistent, so it is a quality which is inversely proportional to consistency. This is what I need you to understand. Variability or coefficient of variation or dispersion is inversely proportional with consistency. Now, as we were discussing about variance, then as we have talked about combined mean earlier, let's also talk about combined variance. See, the value of coefficient is greater the value of coefficient, there is more variability in the distribution. Okay, so should I write that coefficient of variance means that it has greater variability? Yourself understood. So let's now talk about combined variance. Combined variance. So first let me write its formula. It will be given by sigma 1 2 square equals to n1 number of elements of observation 1 plus d1 square plus d1 square. I'll explain what is d1. And 2 to sigma 2 square plus d2 square. Okay. Divided by n1 plus n2. Now, you must be knowing what is n1 here. N1 is simply the number of the number of observations at 1. And sigma 1 square is the variance of observation 1. Okay, what is d1 square here? So d1 is simply the deviation. The deviation di, let me write di. It's deviation of the mean of its set from the combined mean. From the combined mean. So like d1 is the deviation. d1 is the deviation of the mean of set 1 from the mean of the combined observations. Similarly, d2 will be x2 bar minus combined mean. So this is how combined variance is find out. This is how combined variance is find out. Is that clear?
Yes, sir.
Okay, so let's now talk about covariance a little. About what? Covariance. So first, let's talk about correlation. See, there are a lot of topics. Don't have to get confused. Revise the lecture. Let's revise it. In statistical observations, the sum of deviation of individual values from arithmetic mean is zero. That is what we have just talked about. In statistical observation, the sum of squares of deviation of individual values from arithmetic mean is least. In statistical observation, the sum of squares of deviations of individual values from arithmetic mean is least. This, remember, the sum of squares is the keyword here. If each of n given observation is double, then the mean is also become twice. And we know that it depends on the change of origin and scale as well, directly depending. Standard deviation of n natural number. We know we find out the formula for variance for starting n natural number. So standard deviation will be just the square root of that. And this is the formula given of standard combined standard deviation. We find out the combined variance formula. So just the square root of that, nothing different. So this is the coefficient of variation. We have talked about it. Coefficient of variation is directly dependent to variability and inversely to consistency. If each time of a data is increased or decreased by the same constant, the standard deviation of the data remains unchanged, or should and also applicable for variance of the data. Are these points clear? Shall we move ahead to the next topic? Should I explain any point?
No, sir.
No, sir.
Okay. Now let's talk about correlation regression. So before that, bivariate frequency distribution. Basically, there are two variables and the frequency is distributed to them. So in a bivariate frequency distribution, we have two variables of observation on which values are recorded for each unit of observation. The distribution having more than two variables of observation are called multivariate distributions. Here we confine ourselves to the study of bivariate distribution in which two variables may be interdependent. Interdependent, not independent. So maybe there are two observations. Earlier than this, we are only talking about a single set of observation. Then we started to talk about the combining two set of observation. Now we are talking about two set of observation which might be interdependent, dependent on each other, which might be the case. So first, let's talk about the correlation. The tendency to simultaneous variation between two variables is called correlation. Means the interdependence we are discussing about. It denotes the degree of their interdependence between variables. So there are different kind of correlations. There is positive correlation, there is negative correlation, and there is zero correlation. Let's say there are two variables x and y. Uh, X and Y. If I increase X, then Y is also increasing. So that's an example of positive correlation. Okay. If I am increasing X, then Y is not changed. Then it's an example of zero correlation. If I increase X and Y decreases, then it's an example of negative correlation. Are these points clear till now? Are these points clear? Yes or no?
Yes, sir.
So like we have studied elasticity in class 11th physics, that the elasticity is this property. And then to measure elasticity of different materials, we used coefficient of elasticity, right? So similarly, correlation is a property here. To measure it, we'll need some coefficient, and that coefficient we known as correlation. We call it as correlation coefficient, which is denoted by R, which is actually not the second topic. So this is covariance. Let me first show you the R. This is the R. Carl Pearson's correlation coefficient. Talk about it later, but we'll require covariance subtopic to discuss that. So first let's discuss the covariance. Covariance means variance. We have already talked about it. Variance means the change, the variance. It was the measure of dispersion or the measure of variation. That variance was the measure of variation. But this time we are also measuring the variation, but the covariance, they are changing simultaneously. Two set of observations, two variables we have the same. So the covariance between two variables x and y with n pairs of observations is defined as covariance of xy is equals to the sigma xy, sigma, the operator sigma, xi minus mean, yi minus the mean of y divided by n. This is basically the formula of covariance. Very easy for you to remember. There's another form given, that sigma xi into yi divided by n minus of the mean of x observation multiplied with the mean of y observation. So these two formulas are important for you to learn. Clear? Any doubts?
Clear, sir.
Now, if we divide covariance of xy by the standard deviation of x and the standard deviation of y, it becomes a same coefficient that we were talking about, the correlation coefficient, which is here referred as Karl Pearson's correlation coefficient. R is equals to covariance of xy divided by square root of variance of x and y. So instead of writing a square root of x and y, I should better write it as covariance of xy divided by standard deviation of x into standard deviation of y. Better to remember, right? So if I expand the whole formula, it will become R is equals to covariance of xy was sigma of xi minus x mean yi minus y mean divided by n. There was n here, sigma of x and sigma of y is also. So that becomes our correlation coefficient. So that's good enough for us to now. This is the Carl Pearson's correlation coefficient. Let's now talk about its properties. Important. So its range, it lies between -1. It can also become -1, +1. It can also become +1. So R is -1 when it's a perfectly, R is -1 for perfectly negative correlation. R is 0. You might have guessed it. It is for 0 correlation. And R will be +1 for perfectly positive correlation. Okay, that's R. Now, this correlation coefficient is independent of both. It's very important. Both stars. R or should I say correlation coefficient is independent of both change of origin, shows plus minus, and change of scale, which is divide or multiply. Very important for you to understand. The correlation coefficient is independent of both change of origin and as well as change of scale. The correlation coefficient is an indicator for strength of the linear relationship between two different variables. It is the indicator of strength of linear relationship between two different variables, that is x and y, that we are referring to with our examples and formulas. The previous year question asks, coefficient of correlation is the measure of, there was options between central tendency, dispersion, one or both, like this. So let me clear this. The coefficient of correlation is neither the measure of central tendency nor the measure of dispersion. Let me repeat. Correlation coefficient is neither the measure of central tendency, it is not one of the mean, median, or mode, nor the measure of dispersion. It's neither, it's not in the uh, discussion of range or quartile deviation or mean deviation or standard deviation. It is just a different topic, right? So it's not a measure of central tendency or measure of dispersion. Let me also write it somewhere. So these are some very important points from correlation. Okay, so that's enough on correlation. Let's see if there's something left. These properties. Okay, we have talked about it, Coefficient of correlation is a problem where it is independent of the unit of measurement. Yes, coefficient of correlation is independent of change in scale, of change of origin and change of scale. So this is from 0 to, this is, there is positive correlation between x and y. If x increases, y increases. If r is ranging between -1 and 0, then it's a negative correlation. X increases, then y will decrease. If x decreases, y will increase. If r is equals to 0, then x and y are not related. Let's now talk about the regression. So how we have talked about, what is that? In economic market, na? First, tell me, is there any doubt from correlation topic?
No, sir.
So, like we talk about recession in markets, there is regression when we talk about the average. When I call average, I just don't mean mean. It can be the mean, median, or mode. All of the measure of central tendencies. So the term regression means stepping back towards average. Stepping back towards the average. So we'll talk about the lines of regression. So actually, regression topic is based on lines only, like this, how we have studied about the equation of straight line. Similarly, on same lines, we are going to discuss about regression. So line of regression. The line of regression is a line which gives the best estimate to the value of one variable for any specific value to other variable. Repeat, the line of regression is a line which gives the best estimate to the value of one variable for any specific value of other variable. Let's now move ahead to the equation of straight line, which is of our interest. So there are two lines of regression, because as in earlier definition, we have talked about that we will be talking about one variable with respect to the other. So there can be two possibilities that we will find the line of regression for of a particular variable on other depending on other variable. So this is what we are referring to. We are referring to two equations of line of regression. So the first equation of line of regression of y on x, of y variable on x, it will be given by this format, as we know about the equation of straight line. Y minus y1 is equals to slope into x minus x1. This is slope point form. This is slope point form. So now observe here. What is the slope here? This is looking like a slope. Let me do one thing. Slope point form. So this is looking like our slope. Notice the point. Is the point. So our slope is r sigma x by sigma y, which is sigma x is standard deviation for sorry. Uh, sigma y over sigma x, because we are talking about y on x, right? Y on x. So y will be above. Y will be above. So this is the slope here. The point is x bar, y bar, and this will remain the same. Why? Because regression stepping back towards the average, which is x bar and y bar only. So this will be your point whenever we will talk about the intersecting point. The point that whenever we are talking about any point in the regression lines, it will be the mean of x and y. Okay, so there is clear for the equation of line of regression of y on x. Now let's talk about the equation of line of regression. The I should say equation of regression line of x and x on y. So this time x minus x bar is equals to r sigma x over sigma y into y minus y into y minus y dash. So it's actually very easy to remember in this format. Though this is not the correct format to write it, because we write the slope with x. Nah. So this is just unconventional method to write, but it will be very easy for you to remember that you just change x and y, interchange x and y, and then you will have the equation of regression line of x on y. But everything is fine here. Just don't get confused that the slope is r into lambda x over lambda y. No, this is not true. It is not its slope actually. The slope for a regression line of x on y will be, we will rearrange and find out that x minus x bar, if I send everything to this side, sigma y or sigma x into r, this will be equal to y minus y bar. So what is the slope here? Slope is this. Slope is this here. So hence, please don't confuse it like this. Now there's a change here. What is the change? So we actually Let me write on next page. Let's now talk about one by one. So y on x. So y minus y bar is equals to the slope. So instead of writing all that, I am just going to write byx into x minus x. Simple. Slope is byx, which is actually r into standard deviation of y over standard deviation of x. As simple as that. Which will be given by, now please keep this point correctly, which will be given by the covariance of x and y divided by, because it is y over x, so x variation, sorry, x variance. Okay, now what I'm going to write is very important for you to understand. The regression line of x on y. Equation x minus x bar is equals to b x y to y minus y bar. Okay, slope this time will not be bxy, it will be 1 over bxy, 1 over bxy. Now what is bxy? Bxy is r into lambda of x divided by lambda phi, which is actually the standard deviation of x. Standard deviation phi. Formula same. Covariance of xy. Covariance of xy divided by variance of x over y. Na? So y this time it's square because it's variance. Okay. So that's how the formulas are given. This is all what you need to remember for finding out any question of regression line. Simply. Now we will talk about this correlation coefficient little more. After getting to know this formula, now let's talk about R more. Now, before moving ahead, please tell me, are there any doubts in understanding any of this byx or bxy or anything? Yes or no?
Yes, sir.
What yes, sir? Any doubts?
But sir, actually, I understood, but
But
yes, sir.
should we move ahead?
Yeah, sir.
Yeah. So now there are a lot of questions based on R. R is what? Remember, correlation coefficient. Now, there's an important property, the sign. Sign, I'm talking about positive or negative sign. Sign of R, Bxy and Byx are always the same. What do I mean? I mean that if this is negative, then this will also be negative and this will also be negative. If this is positive, then these all three will be positive. If any one of the quantity or measure is positive, then all of these three will be positive. That's the only possibility. So R is find it out by plus minus. I'm talking about the relation between these three. This is very important. Square root of bxy multiplied with b, I should write like this, byx. Very important, very important. Now see, here's an independence. Here is a independence for you to take the sign of rs plus or minus, but that will depend on the signs of bxy or byx. So that's very important for you to understand this point. Very important. Understood?
Yes, sir,
See,
understood.
yeah. See, if any of the sign is not coming as the same, then you yourself make it the same. That's the composition. Let's look at some examples. And these bxy and byx, these are regression coefficients. These and this, these are regression coefficients. Not correlation coefficients. Please don't get confused in between these two. These are regression coefficients. Okay. Now, one important property about regression coefficient. So these bxy or byx. These are two. Okay. The property is if any one of the regression coefficient bxy or byx is less than 1, then the other will be more than 1 because they are inversely proportional. Okay. So if any of the regression coefficient is less than 1, then the other will be more than 1. Let's take some examples. There are some properties. First, let's discuss them. The two lines of regression pass through the point. This minimum. This is the intersection point of regression. Is always passed through their minimum. So their mean. Slope of the line. Okay, we have talked about this. Regression coefficient. This is the regression coefficient of x over y, y over x. Properties, both regression coefficient and R have the same sign. We have talked about it. Coefficient of correlation is a geometric mean. Okay, we have talked about the relation. If one of the is greater than unity, then other must be less than unity. We have talked about this, very important. The modulus value of arithmetic mean of regression coefficient is not less than the modulus value of the correlation coefficient. Okay, this is actually the property which in which we have discussed about AM is greater than GM. We know the AM, if we are talking about BYX and BXY, the arithmetic mean is this, okay, but the geometric mean is equals to R, so that's why they have written RA here. This is same back property actually they have correlated with this, so this is also important. The regression coefficients are independent of change of origin, but not of scale. Very important for you to understand. Mostly people confuse this with correlation coefficient. Correlation coefficient is independent of both. But regression coefficient is only independent of change of origin, not of change of scale. So regression coefficient depends on change of scale. Correlation coefficient is R. Regression coefficient is BYX or BXY. Any doubts from this slide?
No, sir.
Angle between two lines of regression. This is a formula, tan theta is equals to 1 minus R square divided by R. So you don't have to remember the formula. No. You have to remember the formula. Okay, it's important. And these conditions are even more important. Two regression line will be at 90 degrees when they are not related. If R is equals to 0, means they are not related, then the lines will be at 90 degrees. If the lines are parallel, means that the theta is 0 or pi, then they are having some perfect correlation, either positive or negative. Understood? Sigma x, sigma y are the standard deviation. Sigma x square is the variance. Sigma y square is variance of y. R is correlation coefficient. Clear? Yes or no? Understood?
Yes, sir.
Let's take some questions. If regression coefficient of x on y and y on x are minus half and minus 1 by 8 respectively, then what is correlation coefficient? Then what is correlation coefficient? Okay, so bxy is given as minus 1 by 2, byx is given as minus 1 by 8. We have to find r. R we known as plus minus bxy into byx. Okay, we know r is of the same sign of bxy and bix, so they are negative, so r will also be negative. Minus half into minus minus plus 1 by 2 into 1 by 8. So this becomes 1 by 16, whose square root is 4. So 1 minus 1 by 4 is the correlation coefficient. Is this clear? How have I taken only minus 4? And there will be plus 1 by 4 as well as in the answer. And plus minus 1 by 4 as well as in the answer. But you have to pick minus 1 by 4 specifically. Because bxy and byx are of the negative sign. So this will also be the same sign. Clear?
Yes, sir.
Okay. Observe the question. I have to go to the next question. There are two regression lines between height and weight. Height is the variable of x, weight is the variable of y. So there are regression lines given. Okay, regression lines given. Okay, so regression lines are given. Then we have to find out the correlation coefficient actually. So 30x, actually this is a miss. 30x minus 2y. So correlation coefficient is that we need to find out. So we know if we have equations, if we have equation, we have actually everything. So we know that y minus y dash is equals to byx and x minus x dash. If we get this, we'll also able to find out the bxy, right? So first let's convert the first equation in this format and the second equation in the other format simply. Okay. So 4y minus 15x plus 410 is equals to 0. Okay. So how we can do it? First, let's find out y. Then y is equals to 15x plus 410 divided by 4. This is y. Okay. So let me bring it onto the right hand side. Y minus 410 by 4 is equals to 15 by 4 into x. Now this is matching it with this form. So from here we can write by over x is 15 by 4. So from this equation, we have by over x. Why are we finding by over x? Because we need to find the correlation coefficient. We know correlation coefficient can be find it out by by over x and bx over y. So we have find the by over x from the first equation. Let's now find out bx over y from this next second equation, which is 30x minus 2y minus 825 is equals to 0 if my memory serves me right. Yes. So this time we'll find out the equation of regression line of x over y. So we'll find out the equation in this format. Okay. So for this, we need to find out what x is. 30x minus 825 is equals to 2y. Actually, we have to alone sort of keep the y alone. So when dividing by 30, 825 divided by 30 minus 2y divided by 30. Okay, x minus 825 divided by 30 is equals to 2 by 30, 1 by 15 basically, into y. So this has become byxy. Bxy is 1 by 15. We have the same signs. Yes, do we have the same signs, byx and bxy. And here byx is more than 1 and here bxy is less than 1. So this condition is also getting satisfied. You don't have to worry much. And they are both of positive signs. So r will be also positive. Okay, plus divided by 1 by 15 into 15 by 4. 15 by 4. 15, 15 cancels. 1 by 4 is 1 by 2. So R is 1 by 2. It is a very simple question. Right? Understood?
Yes, sir.
Yeah. The concept and the calculation is very easy. Only the topic. First we understand the topic in statistics, then everything is rest is halwa. Okay, let's take one more question. This is a miscellaneous question. If the correlation coefficient between x and y is 0.6 and covariance is 27 and variance of y is 25, then variance of x is what we need to find out. Okay, so first of all, correlation coefficient, as we call it as rho or r. Note, correlation coefficient is also written as rho or r. So its formula is covariance of xy divided by sigma of square of x into square of y. Now, see, this is how important for you to remember the both form of formulas. If you just remember one formula, that covariance of xy is this, and you don't remember the other formula of correlation coefficient, then you are going to get stuck in large calculations. What I'm referring to, if you just remember this formula. Then then you were just going to get stuck in the long calculation. But as we have this data here, covariance which is 27, r which is given as 0.6, and this is given as 25. This is the only value that we need to find out. Now it is easy. 0.6 is equals to 27 divided by 25 into sigma x square. So we can cancel 0.6 and 27 by 3. 27 by 3 is 9. 0.6 by 3 is 0.2. Okay. So sigma x square can be written as 9 by 25 into 0.2 by 10 actually. So now 2 cancels this 10 by 5. 5 cancels 25 by 5. Now it becomes 9 by 5, taking square root on both sides. No, y square root. We need to find this only now. Sigma x square, which is the variance. This is our answer. 9 by 5. 9 by 5 is our answer. If I have not done any mistake. Actually, I have done a mistake. Which is, it was actually standard deviation, not variance. Standard deviation, not variance. So, very standard deviation, it's square root. So this will be 5 here. 5 will cancel 5. The answer will become 9 only. And which is actually the standard deviation. So we need to find out the variance, which will be 80. This is the correct answer. I have थोड़ा याद नहीं रहा formula. You need to revise it again and again. Okay? Understood?
Yes, sir.
There are a lot of questions. Okay, nice. I have put a very interesting question. What is the standard deviation of the observations? Minus square root 6, minus square root 5, minus square root 4, minus 1, plus 1, plus square root 5, sorry, plus square root 4, plus square root 5, square root 6. We need to find out its standard deviation. Okay, we need to find out its standard deviation. We know the formula for standard deviation is square root of sigma of xi minus x bar divided whole square divided by n. Actually, what is n? 1, 2, 3, 4, 4 and 4, 8. N is 8. Now, if you want to find out the mean, which is actually, if we take the square, actually, it is the sum by 8. Okay. Sum is minus square root 6 cancels plus square root 6, minus 5 minus square root 5 cancels plus square root 5. Similarly, everything cancels everything. So the mean is 0. Okay. So standard deviation now becomes easy game for us. Sigma of xi square divided by n. Okay. What square of this? 6. Square of the next term is 5. Then the next term, 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 divided by n. N is actually 8. Okay, nice. So 12, 10, 22, 22, 8, 30, 32 by 8, which is 4. So it becomes 2. Standard deviation comes out as 2. The equation which was looking so typical complex is actually very simple. Clear? Say yes or no. Do you guys have any doubt in using the sigma operator?
No, sir.
Then let's take the example. Arithmetic mean of 10 observations. Arithmetic mean of 10 observations is 60. And sum of square of deviation of extreme values is 5,000. Then what is the standard deviation of observation? This is what I need to find out. Okay. So what do we have? We have the standard deviation. Sorry, the mean is 60. Number of and what else? Sum of squares of deviation of extreme values. Xi minus the mean, which is 5,000 actually. I have missed one thing in question. From sum of squares of deviation of extreme values, then it is from 50 is 5,000. Okay, so there will not be 60 here. There will be also 50 here if that is so. We have the eraser. X mine deviation from 50 square of. Okay, now we have to find the standard deviation. So for standard deviation, we needed to find out the sum of square of deviation, of course, but from the mean, not from 50. So this data is actually not directly useful. So what is useful? As we know, the some standard deviation formula is this when we know the mean. Okay. So we don't have the sum of xi square, which we can get from here. So first we'll expand this expansion. So xi square plus 2500 minus 15 to 200 xi is equals to 5000. Sigma will get multiplied. Sigma xi square, sigma into 2500 minus sigma into 100i is equals to 500. Now, please recall sigma's function. I 1 to n. It's adding this term from n times. So this is what we need to find out. We'll not touch it, right? Xi square as well. Now 2500 is getting added n times. So this will become n 2500. 100i. So this is like the sum of n natural numbers. So actually 100 into sum of n natural numbers. Is this clear that how I've written so? Or should I write I na? I means sorry, not I. It's xi. So 100 can be written out and xi is equals to 5000. Okay. Important thing. We have the mean. So mean is sigma xi divided by n, which is 10. Mean is 60. So sigma xi is 60 into 100, which is 600. So this is 600 into 1000. So this can be written as 600. Okay. So sigma xi square. On to the right hand side, this becomes 5000 plus 600 into 100 minus 2500 into n. N is 10. So 25000. Now let's calculate this. So 60,000 minus 25,000, it is actually 35,000. 35,000 plus 5,000 becomes 40,000. Okay, now let's find out the standard deviation. 40,000 by n. So 4,000 actually, that 10 cancels it. Minus of square of 60, which is 3600. So this becomes 400. So square root of 400 is 20. Easy peasy, cheesy. Clear? You have to utilize every information given. Okay? And you have to remember the formulas. Understood?
Yes, sir.
Hello. Okay, any doubts, any questions from the chapter? We are concluding it.
No, sir.
Okay. Okay, then thank you. Jai Hind. This is a very scoring chapter. Revise it, revise the concepts again and again, and practice it. Thank you, Jai Hind.